The next topic is pivot. So there's a couple functions we're going to see. We're going to see pivot, and we're going to see pivot table, which is sort of a more general version. So depending on what you're trying to do, you might want one or the other. But in this case, based on the values of the columns, you can pivot your table so that you can sort of restructure the data in different ways. It's definitely helpful just to see an example. So first of all, we're going to create a data frame that has 6 rows and 4 columns. And so this first column has, these first 2 columns have strings, and the second 2 columns have integers. So in this case, we're going to run the pivot function. We're going to have our index as this column foo. The columns that we're going to have, the column names will be bar, and the values will be this column baz. So it's going to reorient the data to give us a new perspective. So here we had, so let's look at the values. So these are the 6 numbers in the center here. So these are the values from baz. So here we had 1, 2, 3, 4, 5, 6. We still have those 6 values, but now they're separated in 2 rows and 3 columns based on the values in foo and bar. And so if we have duplicate combinations, I believe that will generate an error, and this is where pivot table is more useful. So another way we can do this is if we don't specify the values, we will get a multi-level column, multi-level columns. So we're going to have columns A, B, and C, and those will be listed twice because those are under columns baz and faz. So this is the same idea we saw before, but now we have multiple levels of columns instead of multiple levels of indexes. So if we wanted, yeah, I can delete this. So if we wanted to just see part of that, we can use the baz column to just get this sub data frame. And so if we look at the columns using the columns attribute, we can see what those levels are. And index is just a regular index. In this next example, we're going to do a few different things. We're going to first we're going to create a create this data frame, which is using this pandas testing function, and then we're going to run this unpivot function, which will yeah, this is complicated. I think let's not worry about how this works because there's a lot going on here. The whole point of this is just to generate this data frame. So we now have dates, variables, and values. So this is a typical kind of data set. And if we wanted all the data for a given variable A, we could do this. We could say I want data frame 2 where data frame 2 column variable is A. And this would just give us this slice of the data frame. But if we wanted to do, say, some time series operations with the variables, we might rather have a representation where the columns are the unique variables and the index is the dates of those observations. So what we can do is we can take this data and we can pivot it. So the index is the date, the columns is this variable that has A, B, C, and D, and the values would be these numerical values here. So we've now pivoted to see each of these columns as each of these variable values, or each of these variables is a column, and we can now see that all the data are nicely laid out here. So, so for example, if we wanted to use Matplotlib, we could plot each of those just using a kind of a very basic syntax here. We can plot 1, 2, 3, 4 series, and then we can do some formatting. We can use the column names as our legend, set the X labels using this year, month, day string formatting for time. This is kind of cool because these X values are going to be these date time objects. So we can string format the date using year, month, day. We can then set the X ticks to these dates and then rotate them. So we now have a plot where we have A, B, C, and D over time looking at the values. So this is a nice way to go from this set of data, but in a way that's not as easily plottable, to a format that can be plotted much more easily. Pivot table is similar, but it can handle duplicate values for a single index column pair. So if we have, I believe this has some duplicates. We can apply, in this case, we can apply an aggregate function, which would be the sum of the values. So this is giving us an example, kind of like group by. And then the last couple functions that I want to cover, and then we'll do an example, is stack and unstack. So this will take a data frame and reduce it down to a sort of a condensed version of it. Again, it's easier to see when we use it. So here we have a data frame where we have all these values in the center. Imagine these are samples. The rows are samples and the columns are features. So this is, say, a feature table of counts. So if we wanted to get all of those counts in a single row, another way we can do that, we saw Melt kind of gave us one way to do that. We can use stack. What this will generate is a multi-level series that has the indexes as our first level index and then the columns as our second level index. So it's stacking up all of the values on top of each other, and then taking the row and column information and using that as the index of that single series. So if we wanted to get that information, for example, we just wanted the information for sample 1, we could do it like this, or we can stack these. We can call these together so we can get the value of a single data point using this is corresponding to the row and the column of the data frame we had before. So there's a very similar function called Unstack, and the way I like to think of this is just it's the exact same as stack, except it switches the rows and the columns. So instead of having the rows as your first index and the columns as your second index, now you have the columns as your first index and the rows as your second index. So taking that same data frame and calling Unstack, we now have feature as our first level index and the sample as the second level index. So again, I can do, I just want all the sample counts for each feature. This is one way to do it. Now typically if you just want this information, you don't need to do stack or unstack, but it comes in handy if you wanted to do some statistics or plotting or something of that as a single column. And again, those output, so if we use the type function, we can see the output of stack and unstack are series, not data frames.